All right. So we're obviously the vast majority of today's focus will be on the exam, but I do want to mention that I have pushed back the due dates for the proposal and the proposal. The proposal is due April 4th, and the proposal is going to be April 6th. Now that day, April 6th, and I will send out a reminder. That is Zoom. That is a that will be done over Zoom, because basically what I'll be doing is I'll be meeting with each student very quickly, or not each student, but each student or each student group very quickly. You'll tell me what your idea is, and I'll okay your proposal. That way there's no surprises as we get later into the semester and I go, that is a terrible idea or something like that. I've dissuaded you from doing something like that. If I have already given your group approval to do the project, either by you just reaching out to me earlier or something like that, then you don't have to show up on Thursday. So feel free to to see if we have if there's time for us to talk, over the weekend or beforehand, because I know that since it's also the first day of Pesach, some people won't be attending. So I just, or otherwise, if you're I know also that some students are on either a conference or they have a sporting event. So again, just keep it in mind. If you missed the April 6th, then, and again, I'll send a reminder, you need to make sure that you meet with me as soon as possible so I can okay it. PIG will be due next Friday. It is the last assignment that is due, the last of our actual assignments. The rest of our time is going to be focused on your final projects and teaching you various other things, only one of which will probably make it to the final exam, which is regular expression. The others will be useful concepts to know for programming in Python, working with Python files, just deepening your knowledge and making it more applicable as possible. But some of it won't necessarily be applicable to everybody. The third exam, which we will do at some point, will be going over the things that we most recently learned, which were dictionaries and Monte Carlo approximations. And they'll probably review anything we have difficulty with on the current exam. So now let's talk about the current exam. As it stands of this morning, because I always make sure, because you know how these things work, you always do it at the last minute. As it stands this morning, the exam currently has 6 questions, which seems appropriate, actually, believe it or not. The main thing with this exam is that last semester I gave pretty much the same exam, and that was given as if in a 15-minute time period, because we did that in lecture, rather than, I think, 70 minutes that you get for the with the group exam. It was either 70 or 75. And I found, and there were a couple issues that went on with that exam. First off, the file reading question was too hard, and that was also the first question, so everybody kind of spent all their time on that one rather than moving that. So I've adjusted that issue. I've made the file reading question much easier or much more simple, like I've said. And I've moved that towards the end of the exam. But the idea here is that each of these questions are very good questions, and they're all represented by stuff that is in the practice exam that we're about to cover. And I figure that we have a good amount of limited questions, just so that we can, just so that you are able to focus on these things and not have to worry too much about the time. Now, part of that is also that for each of these questions, I give you the rubric that both I and the TAs will be using to grade this. So it will say, so if we go to our the practice exam that I'm going to go over here. If I go to this, you'll notice that I've got open it a bit further so there's less. Over here, I have questions that basically say, okay, here's a function, do something with a function. Here's some input-output examples, right? And then code it up. So the questions will so 5 of the 6 questions will look like this. Beneath them will be 5 points, So for this one, it might be 5 points. If this was a 10-point question, it might be 5 points, removing, detecting whether a word begins with in and beginning with un and removing it, and 5 points if you, for adding it to words that don't have it. So the idea here is that, that basically they act as both a guide, kind of do these things in order, as well as like a guide for how you can get partial credit if you know you can't finish all of it or you don't know how to do all of it. This is a great example where it will examine something like this. The file reading question is generally you get 5 points for just reading the file. So the file reading question is going to be 20 points. It's 5 points for just reading the file. 5 points for like parsing, for correctly splitting it into the proper, fields. 5 points for extracting the fields you need. And then, as I mentioned, it was a running sum, right? I'm going to say something like, okay, here's a list of all the animals in the zoo. Please give me the total list of all, give me the quantity of all the animals in the zoo. Something like that. It's not going to be about animals in the zoo because it's just, I'm not going to do that. But it's going to be something like that. So very kind of straightforward, like that. So those rubrics are there to help you. A lot of the question, then for the group exam, I'll be taking some of the questions and moving them to the group exam. I'm going to be taking a question that I've done on previous exams that I found to be the most difficult question for exam 2 and moving that to the group exam instead. And I'll minimize the points on it so that it's not too much of a huge impact because it's more of a reach question, because I enjoy it. It has some, it doesn't have some pitfalls, but it requires you to think about a problem that you may not have had to before. All right, enough of me blabbering on. Let's make sure we can do these. These first questions I don't have an analog to on the exam, but I'll go over them anyway. Again, the main thing is the programming questions. Oh yeah, and you should have gotten an email last night dictating like what the rules for the exam were, but basically you're allowed to use computers, you're allowed to use any IDE, you're allowed to use anything linked to on Canvas. That does include Runestone. You can use Runestone as a reference. You can use all your previous homeworks. You can use anything on your OneDrive. You can't use anything not linked on Canvas. The reason I have these rules is the effect that I want is that you can't go and Google the answers. Make sense? Right? You can't go on Stack Overflow. You can't go and make a post on Stack Overflow asking what the answers are. You can't run to Chat GPT to ask it what the answers are. So that's what the restrictions are. But otherwise, you should be able to code just as you want to. You can use the Python. I don't see any problem with using the Python documentation website. So using the Python official website. I'm pretty sure that's linked to in my syllabus, which is on Canvas. So it is very technically allowed there. Similarly, the Automate the Boring Stuff book would also be allowed because that's also linked to on the syllabus. So there's a lot of resources there. And if there's something you do want to have as a resource that's online, just download it as a static web page or as a PDF. And there you go. This is part of this is because realistically, how many of you code without looking stuff up? None of us do. None of us code. I mean, and you see me do it all the time where I'm not sure what the proper function name is because I work in both Java and Python. And I'm like, okay, is it replace all in Python or is it replace? No, it's replace all in Java. So what's the equivalent in Python? So I have to do things like that all the time. All right. So a couple things to get to go through this. So the string from Howl's Moving Castle is a valid string. Why isn't that single quote in the word? So why isn't that why isn't it a problem that the single quote character in the word Howl's isn't escaped? And the answer for this is that Python's fairly smart. It recognizes that if you use double quotes to enclose a string, that you only have to worry about using a double quote to end the string. So if you use single quotes, you can use a double quote in the middle with no problem, like so. So here, right, I can say ain't, right? That's no problem for it. On the other hand, if I want to say they said, hello, I can use single quotes here to enclose the string, and I don't have to escape the quotation marks because it's recognized as, aha, it started with this, so when I see this, it will end. Now, if I was surrounding it with, now if I did ain't like this, well, obviously it's a syntax error because I didn't finish it. I would have to escape it because because inside of this is the character I'm using to enclose the string. Python's nice like that. Java and C, not so much. Okay, what is the main difference between a dictionary and a list? Everything, but no. Lists are indexed data structures, meaning that they are sequential. Sorry, they have indexes. Those indexes are in orders. These sequential, and it implies that there's an order to the way we do things, although we may not need it. A dictionary, on the other hand, rather than using indexes, uses user-defined keys, which can be anything, not just, they can be numbers and they can be non-sequential numbers, and they can be things other than numbers that are used as keys. However, they are accessed the same way in Python, which is using the brackets. If L is a list, what does the expression L : -1 do? This is a very useful shorthand that I love in Python, which says, give me a copy of the list except in reverse. So it doesn't reverse the list because slices don't, because this is a slice notation, and slice notations don't modify what you're slicing. They give you a copy of what you're slicing out. So this one says, from the beginning to the end, starting at -1, which is the last thing in the list. And Python's, again, smart. If you don't give it a beginning and an end, it's smart enough to figure out what you want to do there. So -1 would basically means, okay, we want to start at the end, so we're going to start at the end and go to the beginning. How can use? Great job. Okay, great job there, past Andrew. How can you use slice notation to get last 3 characters of a string? So given a string, we call it str. All right, in that case, to get the last 3 characters, we can do it a couple of different ways. The verbose way to do that would be, well, we want to go, so we know we want to go from something to the end of the string, and we can leave the end of the string blank to say we want to go to the end of the string. So what matters is what goes on over here, and we could say length of string -3. So, right, if the string is, so if a string has a length of 10, right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right, and we wanted to get 7, 8, 9, we would just simply, we would say 10 minus 3 to go to index 7, and it would give us 7, 8, 9. Alternatively, we can just use that useful negative notation that Python has, and just simply say -3 to the end, because the way to interpret negative is the last, -1 is the last character, -2 is the second to last, -3 is third to last. So negative notation is very useful in Python. It's not necessary. It's a completely unnecessary feature. We could succeed without it, but it's useful to know. Okay, here are all drawings. How can you simulate a coin flip in Python? We can do that with random. So we could do that with, so we would need to, the answer is we would need to import random, and the idea here is we could use random dot rand int. There's a bunch of different ways. One is you could do random.random, which generates a number between 0 and 1, a floating point number, and say if it's less than 1/2, then it's heads, otherwise it's tails. You could do random.int 1 to 2, where 1 is heads, 2 is tails, or 0 is heads, 1 is tails. Anything works there, so long as it's an equally defined 2 choices. Another perfectly valid option is random.choice, the string h, the string t, where random.choice, given a list, chooses one of the 2 things from a list. So that's useful. So the answer is, if it works, it works. This is one of those questions where I keep on to kind of demonstrate that there's a lot of valid answers. There's no one valid answer. If it works, then you didn't break any of the rules that I set forth in a question, then I don't really care how you solve it. Okay. This one's a bit trickier. I have a coin that's slightly weighted in favors of heads. How would you simulate this in Python using the random module? Again, in this case, what you would want to do is that you'd probably have to use numbers rather than random.choice. I mean, if you wanted to do random.choice, again, this is an extreme example. If you wanted to do random.choice, you could say something along the lines of, I'm going to type it out here so that you can read it. You could do something silly like, and I haven't imported random, so, but random.choice, and then, let's see, H times 55 plus T times 45, which gives us 55 heads, 45 tails, right? That's one way to do it. There's a lot of different ways to do that one. Again, it's going to tell me that I haven't imported random. That's fine. Another way to do that would have been with an if statement. We could do something like random dot, we could do that in combination with an if statement saying if it's below a certain threshold, then it's a tail, so long as that threshold's like 55% of the time. So like if we do, here, I'll import random again, or import random gives me a number that is between 0 and 1, and I can simply say, okay, if it's 55, if it's 0.55 or less, that's a heads, else it's a tails, right? I can just simply do a Boolean, add an if statement like that. Okay. All right, file reading. So this is from a prior exam. So in here, what I do in these file reading examples, I don't give you a file. I do list, like, here's an example file, right? You're fully welcome to create your own file to test this out on, or to create the custom file, or to take the example file and test it yourself. But the important thing to note is that a good way to get the question completely wrong is to hard code the question, is to hard code the data into like a string or something, or to hard code the data into a list and not read the file. This is, I'm not saying I want you to read this file. I'm saying to you, I want you to read a file that looks like this. Make sense? This is an example. But if I were to test it, I'd do a completely different file to make sure that, there were no shenanigans with you hard coding the answer or something like that. So suppose we have a file called temperature.csv, which contains the daily high and low temperatures recorded in Philadelphia. I think these are actually actual temperatures for those dates. The file is composed of 3 fields per line. They contain the date, the high temperature, and the low temperature. Each field is separated by comma. For example, the contents of the field might look like this. Write a program that calculates or prints the following: the day with the hottest high temperature, the day with the coldest low temperature, and the average high temperature of the following file. So for this one, for almost every other thing, I'll tell you to write a function. Here, I'm just saying write a program. You can write a function if you want. Here, you can do a program. So let's go ahead, and I will do this as a function just simply because I can keep it separate. So def read temperature, and I'm just going to take in the file name, and I'll say, and this is perfectly valid to do the file name, to do it like this, to take in the file name and to simply say open file name, and we want to do it in read mode, and I'll say data is equal to this. Okay, and that in itself is that, plus doing something like this, either data.readlines or for line in data. That's enough to get 5 points right there off the bat, according to the rubric I have set up. Just or for the one I have set up on the exam. So here, what we want to do though is that this is more complicated than what actually have on the current exam. Because again, this was written for a practice exam, and this came from an exam where you had 2 hours to work as opposed to whatever time I gave you. So here we need to figure out the day with the hottest high temperature and the coldest low. So let's go ahead and create some variables. I'm going to call this one hottest hot is equal to, so what I'm going to do here is I'm going to set my temperature, my initial hot temperature, to be something very low. So, and if you're wondering how I got that, I literally just pounded on the keyboard. Okay. But the idea here is that any temperature is going to be hotter than this temperature. So we're not going to accidentally miss the hottest temperature by setting our value wrong. So for line in data, we want to get our fields by splitting the line up. Line.split. This is a CSV file. So, and we said all the fields are separated by commas. So this will give us so fields now will look like something like this. It will be here's like the date. It will give us a list that has the date, the high, and the low, right? And that's what it's going to look like. So now what we do is that we say, we now that we have the fields, we're looking for the hottest hot day. So what we can do is we can say the high is fields. This is index 1 over here, right? And since it's a number and we're going to be doing comparisons to numbers, we'll probably want to convert this into an integer like this. Make sense? So we split it up. We're getting this field over here, this middle one. And then we can say if high is greater than the hottest hot, hottest hot is equal to high. Now that keeps track of the highest temperature, but we want to print out what day had the hottest temperature, right? That's what the program said. We want to print out the day that had the hottest temperature. So to get full credit on that portion, we would want to also keep track of the day. So not just the hottest hot, but hottest day is equal to empty string because we don't have one yet. And so if that day's high temperature is hotter than the hottest hot that we've seen so far, then we'll say that the hottest day is equal to fields 0, which is the date. So that's the first part. The second part asks for the cold temperature. We don't have to really write a separate program to do that. It's asking for what is the day with the coldest low. So the coldest cold day. So coldest cold, or the coldest cold is equal to, so we're going to give it a really hot temperature because again, we want to be able to, we want a nonsense value so that the very first value we look at is going to be the current coldest temperature. And the coldest day is going to be equal to this. And for the most part, we can just copy paste this, or at the very least mimic it. So so the low is equal to int fields 2 if low is less than coldest cold. Okay, sorry, no. Coldest cold, if it's lowest than the low temperature we've already seen, then coldest cold becomes that temperature. Coldest day is equal to fields 0. So again, we found the one with the hottest hot, we found the low one with the coldest cold day. And now the third part said it wants to know what the average high temperature is for every day. Sorry, the average high temperature of the entire file. So again, to compute the average, what we need to do is that we need to add up all the hots together, all the high temperatures together, all highs, okay, is equal to 0. We're gonna do a running sum, and then we divide that to get the average, right? So we've got our high and our low already, so might as well just do that and just simply do all highs plus equals the high temperature. And then we can print out all the data now, which goes hottest day, coldest day. We can also print out what temperatures they are, but I'm not going to, just to save time. And then we want to do all highs divided by however many we added, which is not something I kept track of. So let's go ahead and do that. Num days. Okay. Num days plus equals 1. Like I said, this one is more complicated than I'm going to do on the actual exam. But this is good, but I feel like this is very good practice for that. And then if we wanted to make it as accurate as possible, we'd do something like read temperature, and that would call temperature.csv. But I'm not gonna go ahead, but I'm just gonna go ahead and comment that out because I don't want to read it right. I don't want to test my code right now. Instead, what we're going to do is that we are going to move forward and start and we're going to start going through the other ones. So the vast majority of the exam is 80 of the points is going to be something like the method writing. I'll come back to this extra practice at the end if people want me to, which is a bit of a different kind of way of doing things. But let's go into these. I'm sure we'll have plenty of time for that one, but I want to make sure I get these. So on or on. This has always been one of my favorite practice questions, which says given we write a function, if the given string begins with un, we return the string without the un. Otherwise, we add un to the front of it. So untied becomes tied, unable would become able, necessary would become unnecessary. And just to make it easier for yourself, we can assume the string is at least 3 characters long, so you don't have to worry about, okay, what happens if I just simply pass the word un? So none of that, right? So this is a fairly short one. We can do, these things are all, this is probably something you'll do similar to what you'll do when you're actually doing your exam, except it won't be embedded into a PDF. It's going to be nice, easy to copy paste HTML. So given this word, so first thing we got to do is detect, does this begin with un or not? If the first 2 characters are un, so there's a couple ways we can do that, which is we can do this the way that is a bit slower and not as efficient, which is, a bit slower, but again, we use what we have. Word, if the first character is equal to a U and word 1 equals an N, then it begins with un. But there's a nice cleaner way to do that, which is to use slicing. So if word from 0 to 2, and we can just simply drop that 0 from the beginning to up to, but not including the second character. So not up to, but not including index 2. If that is equal to the string un, that's a lot cleaner. But there's nothing wrong with writing this one. Nothing wrong on an exam where you're just trying to get it done. You're not going to lose points there. The slices just make it easier. So if it begins with un, we want to get the string without the un on it. So again, if you forget how to use slices, you could do something like this. You could say output is equal to this, and then you could do a for I in range 2 to, index 2 up to the length of the string, and so on and so forth, and get each individual character one at a time and add to the output, do a running sum. Right? Everybody see where I'm going with that? You could do that, but that's not the easiest way to do it. Right? So I'll finish this just for the sake of argument. But I'm going to not keep it. I'm going to delete it very quickly because it's not what I want to do. So for I range to this output plus equals word I. Okay, why is it doing weird output stuff? Weird indentation stuff. Return. Let's see, it's an issue. No. Return output. Right? We could do that, and we could do that. But honestly, that's a pain when we can just write a single return statement, which is return word from the 2 to the n. Right? But would I subtract points if you did the first one? No, that is the point I'm trying to say. Don't worry about, okay, am I doing this the right way? The right way is if it gets done. Make sense? Don't worry about losing points for doing it one way or the other. Think to yourself, is there a more efficient way? If I'm just getting part of a string, should I be using slices? That's what you want to think. Okay, else, if it doesn't begin with un, then we want to add un to the beginning. So return un plus the word. And we can now use these to test. Print untied and print print un on this one. Okay, and run it. And it works as we want it to. Untied becomes tied. Unnecessary becomes necessary. Necessary becomes unnecessary. Okay. So that works. Let's move on to the next one. Min-max difference. Given a list of integers, return the difference between the maximum element and the minimum element. You may assume the list will have 2 or more elements in it. That's not really necessary, again, because if you had 1, it was both the min and max. It would be both the min and the max. But again, I don't want you to have to deal with overthinking some things more than that. So here, again, here I didn't put it into the function calls, but you get the idea. Right? So min-max differently. So again, there is a one-liner for this, which is the difference between the maximum and the minimum. So 5 minus 1 gives us 4. 31 is the biggest number. Minus 15, which is the smallest number in here, gives us 16. The biggest number in here is 100. The smallest number in here is negative 100. So 100 minus negative 100 is 100 plus 100, so 200. That's why we get those answers. So the biggest item minus the smallest item. Biggest item, max of numbers, minus min of numbers. But again, what if you just don't know off the top of your head that Python has min and max built in? In that case, let's totally just use a for loop to do this. So biggest is equal to something really small, smallest, or actually even better, we can say the biggest thing is the first thing. We're gonna assume the biggest thing is the first thing in that list. That's always a good one to do. And so it's the smallest thing. Okay, that enables us to at least initialize the values and doesn't create as many questions. And so now what we do is that we can say for each n in numbers, if n is bigger than the biggest, then the biggest number we now know is n. If n is smaller, and we can do this, you could do this in 2 loops if you wanted, but there's no need to. You could do it one to figure out what the smallest is and one to do what the biggest is, but there's nothing stopping you from doing it both here at the same time. Because smallest, there we go. And then return biggest minus smallest. All right. And again, I'm currently saving this, and it is being saved in my GitHub folder, so I'm going to upload it to GitHub right after this is done. So now let's go to the next one. Swap ends. Given a list of numbers, modify the list such that the first and last elements are swapped. Okay, these first few questions I think are definitely easier, but then as we go on, they become much harder. So swap ends. Given a list of numbers, modify the list. So this is different. We're not returning anything. We're modifying the list such that the first element and the last element are swapped. Now, the key here is that if we're, so here 1, 2, 3, 4, 5 becomes 5, 2, 3, 4, 1. Here the 15 and 28 get swapped, and here these get swapped. Now, the reason why this is one I ask is because it's not as simple as saying one is equal to the other and the other is equal to the other one, because because unless you're doing something very specific, you need 3 variables to do this. You need, right? I can't just simply say, okay, the first thing I'm going to do is I'm going to take this item and move it to the end instead. So numbers, the last thing is equal to this. Because, so this takes 1 and moves it into here. So our list doesn't look like this right now. It looks like this. But now we don't have that 5 anymore, so we can't move it back into the first position. Make sense? So what we have to do before that is we have to say, okay, temp is equal to numbers minus 1. We have to store that item before we override it. Make sense? We have to store it before we override it. And then what we have to do is after we override it, we take the item that's stored and move it to the first position. Does it matter which order we do this in? No. Or rather, it doesn't matter if we do the first, if we are storing this number in temp, or if we're it doesn't matter if we store the first thing in index 0 in temp or index last in temp, as long as we do things in the right orders afterwards such that they don't get overridden inappropriately, right? You store your item, you overwrite the item you've stored, and then you use the stored item to overwrite the item that overwrit. Or in this case, we store the last item, we take the first item, move it to the last location, then we take the stored item, which is 5, right over here. And we don't need to return anything here because it says to modify. All right, this is one I threw together to make sure you had plenty of more, last week, to make sure you had plenty more practice. Given a list of things, return the first half of the list. So here, 1, 2, 3, 4, 5, 6 gives you 1, 2, 3, 15, 31, 21, 17, 28 gives you 15 and 31. And just to be clear, that's not just numbers here. A, B, C, D, E, F, G, H gives you A, B, C, D. And also to be clear that we're not just dealing with things that are, you know, 5 or 6 long. Notice that this one's 5 long, and I said I want 15 and 31. So I do care if there's an odd number of elements, but the way I have it set up is that it's kind of the easier way. So let's go ahead and think about having an even number of elements, right? And then we'll figure it out from there. So here we want to go, so for this one, this is 6 items, right? This is 6 items, meaning there's 6 items in here and I want half of the items. So I want 3 items. The first 3 items are located at one index, 0, 1, and 2. So if I want to get them, I can just simply grab them with a slice that simply starts at 0, goes up to, but doesn't include, well, we want the items 0, 1, and 2. So it doesn't include 3. Make sense? Specifically, it doesn't want this 6 divided by 2. So let's see what happens if I generalize that into instead saying up to but not including length of the list divided by 2. So in the case of this, the length of the list is 6 divided by 2 gives us 3. Going up to but not including index 3 gives us indexes 0, 1, and 2. Now over here I have 5. Divide that by 2, that gives us, well, that gives us 2.5. So that doesn't work, but so instead we're going to need to use integer division. So let's see. 5 divided by 2 using integer division. Its quotient is 2, its remainder is 1, so it gives us 2. So in this case, let's see what happens if we use this. Go up to but don't include index 2. So get index 0 and 1. That actually, as the answer gives us that. Now let's go and look at A, B, C, D, E, F, G, H. That's 8 long, divide by 2. That gives us 4. Let's go up to, but not include index 4. So the answer is actually very short if we use a slice notation over here. So the answer is very short if we use slice notation. Copy. Return the list 0, which we can leave blank if we wanted to, up to, but not including the length of the list, divide by 2. Okay. Now, one of my other ones that we've had, right? And I've always, now this is one where we do get into where we start getting stuff that is a bit harder. So write a method called hasWildcat. Given a input string, string word, return true if the string contains cat in it, but the middle A can be any character. So kitty returns false, tomcat returns true because it's got CAT, and catnip written in leet speak is true because we've got C4T, right? So the middle character, so in other words, we're looking for C anything T. All right. So this one is interesting because if you want to use slices, you because we could use slices over here, but I'm not going to. Slices involve, I mean, there's a couple different ways to do this. You could get this, you can look at a rolling slice of the characters and say, okay, does the first letter of the slice begin with a C, and does the last letter of the slice begin with a T? Oh, sorry, is the last letter of a slice of T, and that would do it. But the important thing here is because we have to look at multiple characters at once, we have to iterate through this using an index. So what we're going to do is that we're going to assume that this does not have a wildcat in it. Okay, we're going to assume that it returns false, that we've got nothing here. So what we're going to do is we're going to say for I in range. So what we can say is for I in range from 0 to the length of the word. Alternatively, we could just do enumerate to get both the index, the letter, and the index, but that probably doesn't necessarily register in the same way. And actually, as we'll see, that would present problems later. So this way I am going to leave an error in this for a bit, and then we're going to go back and fix this. Because so let's go ahead and see this. So for I in range, what we want to do is we want to ask so if word at I, so if the ith letter is a C and word I plus 2 is equal to a T, return true. Okay, now here's the thing, we don't need an check what I plus 1 is because we don't care what it is, right? It can be anything. So if word I is equal to C and I plus 2 is equal to T, return true. Now, a lot of times when I see this, I see a common error in this kind of problem where I'll see this, else return false. And this is mega wrong, okay? Because what that would do is that you look at index 0, and if index 0 had C and index 2 had a T, great, we found a cat, return true. But then you would say, well, if index 1 didn't have it wasn't a C, and index 2 wasn't a T, then return false. And returning, remember, stops the program. So you'd only ever check the first letter. You'd only ever check this. You'd only ever check these first 3 letters. So you only want to return when you're sure about it. Generally in a for loop, if you have an if statement and a return, you don't want the else to also return. It's generally, you probably don't even need an else in that case. So assume something is either true or false, and then use the for loop to disprove it. Now, if we run this code, I'm going to compile this. If we run this code on over here, has wildcat, this should return true just as planned, and this should return error just as planned. Oh, so it returned true. On the other hand, this one will return error. Sorry, this one should return error. No, it returned false. Interesting. Normally it crashes when I do that. Why didn't it crash? Because normally this crashes because I plus 2 should be an out of bounds error, right? So I'm very curious why that didn't crash. Wildcat false. So let's see. Interesting. It's so weird. Normally I make a big deal about the fact that I plus 2 should go out of bounds. Okay, let's go ahead and time to debug. Okay, and because I am wondering why I'm wrong. Print I plus 2. Print I plus 2, word I plus 2. Okay, and now we can say, there we go. No idea why that wasn't crashing beforehand, but the idea here is that, right? I'm looking at index. So here we're looking at Kitty, 0 and 2, that's KT, 1 and 3, that's IT, 2 and 4, that's TY, and then 3 and 5, well, there's no index 5, so that would give you a issue. I'm just very curious as to why this isn't here. Maybe it's Python being awesome. Yes.
But if you want memory efficient with this check, C is in Word, if C in Word, or that in the Word, or as you index and check it to above that is C.
There you might have more than one C. And so the C in Word, and then storing you'd have to store multiple indexes. Yes.
There's no C in Kitty. That part of it's always false.
Ah, yes. Thank you. There we go. Thank you so much. That's right. I didn't have a good test case in here. Okay. So we can do, so in this case, we can do this. So we can run this, save it as Wildcat, and there we go. Thank you for pointing that out. Oh, and yep, and somebody mentioned it in chat as well. Sorry for missing that. Thank you. All right. See, I'm not infallible. All right, so let's go ahead and I grabbed this one from CodingBat. So we'll say a value is everywhere if for every pair of adjacent elements in the array is just what they call a list in Java, at least one, and that's a lie, but it's close enough to the truth for the purposes of this exercise, that at least one pair is that value. Return if true if the given value is everywhere in the array. So here it's asking if for every pair of adjacent elements is at least one pair of this value. So 1 is everywhere because because this has a 1 in it, this sub run has a 1, this slice has a 1 in it, and this slice has a 1 in it. Make sense? So all these pairwise adjacent slices has a 1 in it. Here, this slice has a 2 in it. We're looking for 2s now. This slice has a 2 in it. This slice has a 2 in it, but this one does not, so we return false. And then over here as well, this one is false. It's the same as above, except that we've added a 4 to it. And in this case, again, we don't have that. So again, to solve this one, we need to rely on slices. A lot of these have more slices than I actually have in the exam, I think, but that's fine. They're still valuable. So same idea. So, oh, right. I never even fixed this one. So how do I fix this issue with it crashing there? The answer is that I don't go beyond, I make sure that I stop before I get there. So length of word. So length of word would be the last character, -1 would be second to last, -2 would be third to last. Let me go ahead and make sure. Yes. So let's see. The attack. False. There we go. So because I'm looking ahead to over here for this one, you want to subtract 2 from the range. Similarly over here, because we're going to be looking 1 ahead, we'll just want to subtract 1 from the range. So for I in range 0 to length of nums -1. And here we can use the suggested in operator, which is going to make this a lot easier. If val in nums sliced from I and we want the next value, which would be I plus 2. So if it's in this value and the next value, then, sorry, well, in that case, that's what we want. So so it's easier to show that it's not in it. So we would say, if it's not in it, return false. So if the value is not in this pairwise thing, return false. Otherwise, we get to the end, it was in every single one of those pairs, return true. You didn't see anything. Okay, there we go. And so now what I can do is I can test this. False. True. So, and again, part of what I do over here is make sure, since I'm going to be looking one ahead, because this goes up to but does not include this one. Another way we could do that, if that I plus 1 really bugs you, is that you could say a list of nums I and nums I plus 1, right? And that works as well. All right. Next one. Just trying to make sure that I hit all of them. All right. Given a string, return the sum of the digits in the string, ignoring all the other characters. Return 0 if there's no digits in the strings. So string.isDigit tests if some string is one of the characters 0, if it's one of the characters we care about. So here, right, we have A1, B, C2, D3. There's a 1, a 2, and a 3 in it, so we make 6. This one has a 1 plus 1 plus 3 plus 3, that becomes an 8. And chocolate, while delicious, has no numbers in it, therefore we give it 0. Only it was 0 calories. All right, so I do love my chocolate. I have quite the sweet tooth. But unfortunately, the 5-year-old inside of me is very disappointed to realize that adults have to be responsible and not eat chocolate all day, I mean, I could. Will I post this recording by tonight? Yes. So let's see. So here what we need to do is that we are doing a running sum. So total is equal to 0. At the end, we are going to return that total. And what are we going to do now? You're going to say for character in our word. For every character in this, or every letter in this, we're going to ask ourselves, is it a digit? You find the recordings on the front page of Canvas. You look for lecture recordings, and there's a big playlist. That'll bring you to a page with a bunch of playlists. So for character in word, if char dot is, let's see, did it say is, no, it's underscore. Okay, sorry, an undercase, is digit. If the character is a digit, great, then it's one of the ones we want. So we would say total is equal to total plus that character, except of course, we add this. Well, you'll see in just a second. This is one of those cases where you want to be careful, because if we do this, it will say int and string are unsupported. Oh yeah, because I'm trying to add because I try to take a 0 and then I try to add the string 1 to it, which is the error I was looking for. Forgot that I declared this. I was expecting it to be the string 1, 2, 3. All right, so there we go. So instead, what we do is that in order to handle that, we need to convert that character into an integer. We get 6. And we use return because we want to because if we didn't return, it wouldn't let another function use the other function's output. So if I've got a problem that requires another function to use, so if I've got a two-part problem, returning from the first function allows the second function to use it, which makes the second function's code a lot simpler and neater. Similarly, so in a similar vein, given an integer, return the sum of the digits 0 through 9 of that integer. So here we're not given a string, we're given a number. And we've done this one in class a couple times, but it's worth reviewing. There's a couple different ways to do this. Sum of digits. Right here, we add up all the digits. It's very similar to the one above it. In fact, one of the ways we could do that is that we could be really lazy here and simply say, okay, total is equal to, or we could say we could say num string is equal to num turned into a string. Turn it into a string and simply return some string digits of our num string, and that's and call it a day, right? Okay. In other words, we just simply, end result, the first solution and the most common one I see is that we just simply turn it into a string and then add up all the digits. This is not computationally efficient, but I mean, like, it's fast, fairly fast. Your computer doesn't really care. Although, and yeah, over here we get kind of the same thing. It works as well for the negative number, because negative isn't one of the digits we're adding. So it's kind of just looks, so it says it's not a digit, so we add 5, 8, and 1, and we're good to go. Okay, so what do we do on the other hand if it's a but what if I had a restriction saying you cannot change the number into a string? How would we solve it? Well, in that case, we have to use modular division and division as well. We have to use math. And so what we do in this case is that we, again, have a running sum. Although in this case, what it is that we have total is equal to 0. While total is less than, while total is while num is greater than 0. I was conflating what I was going to do here with our ending condition, with our end, which is return total. Okay. So what do? We say num. So what we need to do, given a digit, what we want to do if we want to add this up without converting it is that we need to extract one digit at a time. Now we know the easiest way to do this is to get the ones place. And the way we do that is we can say the ones place of this number is equal to the number mod 10. That will give us the last digit. In fact, let's go ahead and rename that. Last digit of the number is equal to that number divided modulo 10, right? Because if you divide by 10, the remainder is going to be the ones place. So then we can say total plus equals the last digit. And we can then do, and then what we need to do is that we need to make sure that we can move on to the next one. So we can then divide by 10. If we divided 1, 2, 3 by 10 using integer division, if we divide 1, 2, 3, 4 by 10, right? 1, 2, 3, 4, divide by 10 gives us 123. 123 divided by 10 gives us 12. So by using that, we can keep moving forward. So num is equal to num divided by 10 effectively removes the last digit. So we get the last digit, add it to our running total, divide by 10, and we're good. So over here, we can say sum of digits, print. And what happens when we get to the ones place, or get to the highest place over here, like the one over here? Well, we'll take the 1 because 1 mod 10 is 1. Then dividing it by 10 gives us 0 because 10 can go into it 0 times. And so that hits our end condition. Okay. And now, okay, now let's see. So how many more problems do I? Okay, last one. Extra practice. Given a list of positive integers, return a new length of count containing the first even numbers from the original array. Ooh, that one, it does sound tricky. The original list will contain at least count even numbers. So that's just promising us that we don't have to worry about that. So copy evens. So we want to grab, so this one says, here's a list. I want to grab the first 2 even numbers. So 3, 2, 4, 5, 8. The first 2 even numbers would be 2 and 4. The first 3 even numbers would be 2, 4, 8. And here the first 3 even numbers would be 6, 2, and 4. Now, the reason why it's like going into this and saying that the original list will have at least as many as we ask for is because Python, lists are malleable, but in other programming languages, we would have to, you have to define how long you want an array to be in advance. And then you can't change it. With lists, they can change their length. Again, coding beta is pretty good for these kind of exercises. They have more exercises in Java than in Python, but there's nothing stopping you from changing those Java problems into Python problems if you need more practice. And that's linked here in the practice exam. So copy evens. So again, our output, we're going to have an output once again. But in this case, our output is going to be an empty list. Return our output. And what we'll do is that as we find even numbers, we will, as we find even numbers, we will add them to our output. And there's a couple different ways we can go about this, depending on your personal preference. But for right now, what I'm going to do is that rather than worrying about grabbing the first 2 or the first 3, I'm just going to try grabbing all the even numbers, or number, or n in nums. So that's our list, or n in nums. What we're going to do is we are going to say if n is even, we check if n is even, if n mod 2 is equal to 0. So if we divide it by 2 and it has no remainder, so modulo 2, no remainder, that's equal to 0, that number's even. So what we do is we say output dot append n. There we go. So over here, what we'll do is we'll run this, and then I can test this over here, copy evens. Oh, and it's saying you misspelled things. So thank you. And that gives me 2, 4, 8. It gives me, because I asked for all the even, because I wrote my code to do all the evens. I said I'd address how to get everything in there later. So there's a couple different ways we can go about this. The first is that we can be very manually controlling about this, which is a bit more efficient. We can say if the length of our output, if the length of the list is equal to our count, equal to the amount we want, then we can just simply return our output there. Just stop the program. Also, what would also putting in a break right here would work. Either works. So those are two possible solutions there. I think this is the more elegant one to do in that case. Or you can use slices to say, okay, well, I got all the evens. So instead of stopping prematurely, I'll still get all of them, but I'll just simply show you the first count of them. So if I want, so if count is 1, it will give you, so if count is 1, it will give you the first item. If count is 2, it will give you the first 2. And if count is 3, it will give you 3. Because remember, how long is a slice? It's a slice's length is equal to the end index minus the start index. So count minus 0, it's count number. Make sense? So if I put in 2, this length of this is going to be 2. Oh, again, and part of that illustrates again that all of those are valid solutions. Anytime I can say you can do it like this or this or this, I don't care which one you do. Okay, I'm trying to show that you have flexibility. So let's go back to that final question that we did all the way at the beginning that I said let's save for later, and I'm sure we'll have time. And look at that, we do have time. And because I want to end it up with one more file reading question. Suppose we have a file named numbers.csv that contains a bunch of integers, 5 per line of text, separated by commas. Write code below that will open the file, read the numbers from it, and print the sum of all the even numbers in the file. So for example, we might have a file looking like this. It's just, again, honestly, the 5 per line of text doesn't really matter. We could have it jagged and write our code to work the same way regardless. Jagged meaning that it's not a nice rectangular piece of data. Instead, one row has like 10 columns, another has 5, and another has 16. It doesn't matter. So, but the 5, I mean, makes it more predictable. So let's go ahead and do def read numbers file name. Once again, what we'll do is we'll just simply do a data is equal to open file name R, and once again, and we could do something like 4 line in data. Instead, though, to just make sure that you understand that there are multiple ways to do this, you can do we can do lines is equal to data dot read lines. I think that's how we do it. I think it's read lines, all one word, lowercase. Okay, and then for line in lines. And of course, since this is a running sum, we will want a total is equal to 0, and a total is equal, and then at the end, return total. Or we could print out the total because it's a file reading one, and I said you could return or print, I believe, or I just said give it. So over here we have, so here each line looks like this. Each line looks like X, Y, comma Z, A, comma B, where A, X, Y, Z, A, and B are all integers, right? Looks like this. So, and they're all separated by commas. So we'll go and say parts is equal to split, or line dot split on the commas. And this gives me now, and that transforms that into something that looks like X, Y, Z, A, B. So rather than being a string, So rather than this being a string, parts is now a list, which is a bit easier for me to deal with. Because if it was a list, I can only interact with one character at a time. Here, I can actually interact with one number at a time. So now what I could do is I could say, for val in parts, so for every one of those values, I could say total plus equals val. Sorry, total plus equals val, except each of these is actually, well, each of those is a string right currently. So that wouldn't work. So I have to remember, since I am working with files, and files are just a bunch of text, anytime I want to actually work with numbers, I have to tell it if a certain thing is a number. Make sense? So we take that and we add it. And here we go. This is actually very similar to what you will probably have to do for your problem tomorrow. Except you're not adding everything up, you're adding a specific column. So, all right. So that is our practice exam. Any questions about, yes? Oh, all the even numbers. Hey, I misread a part. Guess what happens when I do that? Do I get the entire question wrong? No, there's the rubric. There will be a rubric which will say how much important each part is. So if it's all the even numbers, that was totally my intention. It was just a test for all of you. No, I totally forgot about that. It's no problem to add back in though, right? If this is mod 2 equals 0, so if that is even, then we add it. So we just add an if statement right there. Okay. Other questions about this or the test tomorrow or tomorrow on Monday? Yes. Is that when you normally go to the lab? Then some of these, yeah, it's when you normally go to lab. I don't know which lab which days. They always switch it on me each semester, so I don't. So, okay. Now, remember it is open book, and then there's other, and then I have a specific amount of electronic resources. When in doubt, just ask. And I will be and again, there will be a group portion to this. So, and once again, if you have if something happens that you cannot take, so just want to be clear here, because there was confusion last time. Yes, sorry. And for OpenNote, can you go on GitHub? If it's your GitHub, sure. Or my GitHub. But I want to be clear, you have to be physically in lab tomorrow to take the exam. Okay. Otherwise, we can't proctor you. If you cannot make it to lab tomorrow because Murphy's Law, then email me as soon as possible. Murphy's Law, whatever can go wrong will go wrong. Okay. So if you cannot make it to lab tomorrow or Monday, email me, email your TA. It's not a problem. If you're sick, same thing. Okay. Religious obligations, same thing. If you don't feel like you're able to take it because of religious obligations, let me know and we'll find an alternate time.
You said it's okay to use
And Jay, no, it doesn't matter.
Just okay. You said it's okay to use Runestone, right?
Yes, it is okay to use Runestone. Let me go ahead and before I forget, I'm going to upload this to GitHub. Okay. Stop share and stop recording.